Just like you have a system of equations, you can have a system of inequalities. So an inequality just uses less than or equal to, greater than or equal to, less than or greater than symbols. So just to review back, you use a dash line when you have a less than or greater than symbol, and you're going to use a solid line when you have less than or equal to or greater than or equal to. The solution of a set of inequalities is all of the ordered pairs that satisfy it, so where your shading overlaps. So I'm going to shade graph this first line, which you're going to start at 4, and your slope is -2, so I'm going down to right 1, and it's going to be a solid line, and I'm going to shade less than. Okay, for the second line, I'm going to graph a dashed line. Now remember Hoy-Vox. So if you have x equals, it's going to be a vertical line. Vertical line, slope undefined, x equals. So x is greater than -3. So I go to -3 on the x-axis and make a dashed line. And numbers that are greater than -3 on the x-axis are going to the right. So where this overlaps is my solution. So any one of these ordered pairs can be substituted back in for x and y, and they'd both be true. That's how you can check yourself too. Okay, letter B. I'm going to graph x is less than or equal to 3x minus 6. So I'm going to start at -6 and go up 3, right 1. And so I'm going to make a solid line and shade less than, because I'm going to shade underneath it. Remember we talked about putting a ladder and it's less than, so you shade under the person. And then y is greater than -4x plus 2. I'm going to start at 2 and go down 4, right 1. Now this one's going to be a dash line, or up 4, left 1. So dash line. So again, with your shading, when it's close to vertical, it's kind of harder to tell. But remember, put somebody on this ladder. So if you were climbing up the ladder, you'd have to be on this side of the ladder to hold on. Okay? So if you're climbing up the ladder and it's greater than, you're going to shade above the head. So above the person's head is going to be on this side. So where they overlap, you should darken, is going to be your solution to the inequality or to the system. You can do the same thing down here with absolute values. So I'm going to graph y is greater than or equal to x. So that's going to be y-intercept is 0 and the slope is 1. So make a slope of 1, y-intercept is 0. It's going to be a solid line. Now also think about putting, if you're shading, it's greater than, so the person is going to be on this side of the ladder because they would fall off if they were on this side. And then it's greater than, so you're going to shade above. And then less than, this is absolute value. So remember, absolute values make V's. So we want to find the vertex. So the vertex is at -5, -2. So I'm going to go left 5, down 2. And it's going to be, the slope is 1, so I'll make a V that opens up. So I'm going to go up 1, right 1, up 1, left 1. Make a solid line. And I'm going to shade less than. So when you shade less than for an absolute value, you're going to shade underneath the vertex. So all of these points are underneath the vertex. So now I'm going to darken the solution here. And then B, these are both going to be solid lines again. So I'm going to start at 4 and go down to right 1, down to right 1, and then it's greater than. So again, put somebody on the ladder. If you put them on here, they'd fall off. So if I wrote put someone in the ladder right here. It's greater than, so you're going to shade above their head. And then the second one is going to make a V, so you're going to go right 4, go up 1, right 1, up 1, left 1, up 1, right 1, make a solid line, and I'm shading less than, so I'm shading underneath the vertex. So the vertex of an absolute value function goes like this. It's right here. The reason I know it makes a V is because it's an absolute value function. And now I'm going to darken or put in green on my paper where they overlap. Sometimes you have to go backwards and write a system of inequalities. So to do this, I break it up into a process here. So there's 2 lines that are intersecting. So I'm going to call this one line 1 and this line 2. So look at the slope of line 1. So the slope is going up 1, right 1, up 1, right 1, up 1, right 1. So the slope is positive 1 and the y-intercept is negative 5. Oops, I did the wrong one. I did line 2. So I'll call this one, I'll just switch these up. So this will be line 2, this will be line 1, this will be line 2. So now let's look at line 2. So the slope is going down 1, right 1, down 1, right 1, down 1, right 1. So the slope is negative 1 and the y-intercept is 5. So the system for line 1, you're going to have this line and you shade above it. So it's going to be y is greater than, the slope is x, and then minus 5. Now, it's greater than because if this is line 1, it's shaded above it, and it's a dashed line. Now I'm going to do the second one right here. So the second line is still shading above, so it's going to be y is greater than, but the slope is negative x plus 5. So those are the steps that I'm doing. I'm identifying each line, finding the slope and the y-intercept, and figuring out how it's shaded. Okay, down here, line 2, we'll make line 1 this line, and this line 2. So line 1, the slope is negative 1, and the y-intercept is 4. And I'm already going to write my system for it. So it's going to be y. Now, this is shaded underneath line 1. So it's going to be less than or equal to, because it's a solid line. So negative 1x plus 4. Line 2, the slope is 1 and the y-intercept is negative 2. And it's a dashed line shaded above it. So it's going to be y is greater than x minus 2.